We moved into this office about 1.5 years ago, but before we were in this office, we were in a co-working space down on Scarlett Street, which was called Full Node, which really is like a Web3 co-working hub, and we had our permanent offices in there. And our direct neighbors through that time in Full Node were Gnosis. And so we've actually managed to build quite a lovely relationship with them. And that leads us into our next talk. Gabriel is from Gnosis. He is an LLM engineer who is focusing on developing AI agents for prediction markets. Welcome to the stage.
So hello, everyone. Happy to be here. I'm Gabriel. I'm with Gnosis AI, and today we'll be talking a little bit about how can blockchain help decentralize AI. Yeah, this is a brief agenda for my talk, but just a very brief introduction to Gnosis and what Gnosis has been doing in the last years. So they started actually in 2015, building prediction markets for Ethereum back then, was one of the first applications. Then they developed a couple of different infrastructure projects like CalSwap, Safe, which is also a self-custodial wallet, and now most recently, with Gnosis Pay and some other financial infrastructure for payments. They've been shifting a little bit to this other vision of payments and financial infrastructure. And one tiny application of that is prediction markets, and that's really what Gnosis AI has been focusing. So we've been building AI agents for those applications. But coming back to my agenda here, so I'll start with an ultra short introduction to LLMs. So just to make sure that we are all both on the same page from a technical level. Then I'm going to make the argument that we need decentralization for those systems since they are so powerful and they pose threats if centralized. And finally, I'll come to the interesting part, which is 2 examples that I highlighted of ways to decentralize the tech stack with crypto then. Cool. Yeah, so here it's not about really giving an overview of transformers or how they work, plenty of resources for that, but it's more about why now. So why have those models have become so popular? So what has enabled that? And mainly 2 things. So first one is really the transformer architecture with specifically the attention part, which allows the processing of data to be done massively parallel. So that has allowed the models to really increase a lot. And second is really the encoder and decoder architecture, which also allows the model to kind of understand more complex relationships between the different sentences. So those 2 things have really allowed those models to explode, become very, very large, and to do all those interesting applications that we see nowadays and that we also saw in the previous presentations. Also wanted to highlight one important thing for the rest of the presentation, of course, massive data used for training, so orders of trillions of tokens. And the second thing is really the way that those models are also using. Initially, text-to-text was really dominant, text summarization, generation, and so on, still very prominent, but now some other models like multimodal architectures are also readily available. Awesome. Then the reason for needing decentralization. So don't really need to make this point that LLMs are extremely powerful these days, can do many tasks very, very well. So scientific articles being one of them, but also in my field, software engineering, we really can go away from that. And having a few for-profit corporations with this amount of control, power, influence, of course, poses several risks. And don't really need to remind you guys, but 4 of them that I listed here, maybe bias and abuse being the one very, very important ones, in the sense that every company or tech provider might understand alignment in a different way of those models. So they might, intentionally or non-intentionally insert some bias into their models. It's their way to view the world, and that might not align with how the users are thinking, for example. Also interesting is the abuse case that I described as abuse, but maybe there's a better word, in the way that I'm the model provider, and depending on what the user is looking for, so searching for a car, I might prioritize brand A over brand B, and that's maybe not in the best interest of the user, but rather my personal commercial interest. So yeah, that's also a threat as I'm describing it. And the real question, so the next question is, which components of the system can we decentralize? And those are the two examples that I'm going to give. So the first one is the data collection. Current foundation models train on, that's the order of magnitude. Not sure how accurate that is, but 40-50% of the internet is being used already, the public data, for training those models. So massive data, as I mentioned, but that's slowly becoming clear that that's not going to be enough for the models to really improve and get even better and achieve the scale or AGI or SI or what we are really thriving with those models. Then obvious next step is personal data, this is one of the projects I wanted to highlight, which is Vanna, and they have some interesting concept called data ownership. So they're trying to really connect the data pools here, so private data, for example. One big example is Reddit DAOs, so lots of private data around Reddit, with the model, let's say the software, the AI model developers, let's call them like this. So the model software engineers, and the idea is they connect those people that want to have access to the Reddit data in this example with who wants to train the model. And the interesting thing is me as a model provider, I only have access to the data if I also mint my own LP tokens, so to say, and those tokens are then transferred to the users, and the users, as the user contributes with their data, it gets a proportional ownership of the model being trained. So after the model has been trained, if it generates any kind of revenue afterwards or is being served to users, parts of those proceedings, parts of that revenue are being forwarded back to the users providing that data. So it allows the users to participate on the profits. And an interesting point that I also wanted to highlight is that they have one interesting topic of proof of participation, in the sense that, proof of contribution. And the idea is, let's say you're still using the Reddit DAO as an example. If my private data there helps the model a lot, I post about different topics, I have a greater variety of information, I should have a bigger contribution than someone who logs in just once or twice and does some kind of small comments there. So I would be entitled to a larger portion of the proceedings than this other person, which has, let's say, a lower contribution. That's also something that they brought in. And yeah, the last point I also wanted to mention is training. So this is slightly more technical. And so decentralized training, what is it about? It's related, of course, the fact that training of those large systems, as I alluded earlier, is very data and compute intensive step. And since tons of resources are required for completing this step, it has been overall dominated by big tech. So those are the big corporations that are basically the big foundation model providers. And as I alluded before, that poses some risks, and decentralization is a good idea. Especially open source models. So having those kind of decentralized infrastructures would allow more people to have access to training, thus developing models which hopefully can also be open source. And very importantly is also this point of tap into broad resource network, because for training those models, you can also tap into those somewhat idle resources, not really GPUs, but also everyday CPUs or some other data centers that might be idle for one reason or other. And those can also be used for training. And those are, and yeah, as highlights, I had plenty of startups are working in this space. 3 of them I wanted to highlight is, of course, Now's Research, which has been working on the Solana ecosystem, Prime Intellect, with their new model Prime 1, and some other open source contributions, and Jensen. Oh, Prime 2, thanks for that. Intellect 2 as well. Thanks for that. We'll fix the slide. And yeah, maybe starting with the challenges, communication is a big one, right? As you have different nodes trying to run training, of course you need to communicate between those nodes or between a master node and the other nodes in order for them to kind of work asynchronously, but also communicate the updates as you're completing training. So that's, of course, one big challenge there. And another big challenge is this memory sharing or data sharing between the nodes. So, of course, you probably don't want to copy all your data over all the nodes. So it's a challenge to know which parts of the data, how you shard that, and how you propagate those weights back into the main model, so to say. And another challenge is verifiability, and that's really where crypto comes into play, together with incentives. And coming back to the whole talk of my presentation, Thank you. And coming back to all my whole talk of the presentation of how crypto can add value or can help decentralization is really 2 points here that I think. The first one is, together with Vana, was really just transmitting value efficiently. So tokenizing the participation of the nodes here. So let's say I provide my GPU there for 1 hour, I get 1 token. If I provide my GPU for more time or can have more nodes, of course I have a larger token allocation, so I'm able to have a larger incentive to participate. And also verifiability is a big one, because crypto is needed here, because if you have several nodes and it could be that some of the nodes are not completing the training properly, or they're going rogue, or they are introducing some artifacts in the data that you don't want to. Having the blockchain in there, providing like a immutable, censorship-resistant ledger makes sense, because you can afterwards verify and, if necessary, slash those participants so that they remain financially incentivized to participate and provide meaningful value and meaningful contribution to that training. Yeah, that's about decentralized training. One point I also wanted to make is that decentralized training is different from distributed training, which big tech is also already doing these days. But distributed training is simply about, instead of having a very large data center, you simply kind of distribute that across multiple sites. And but those sites are basically homogeneous, so it's not like you have 1 GPU here, 1 CPU, 1 cell phone here to train the model. It's more about just geographical distribution, whereas decentralized training is mostly about working with a heterogeneous infrastructure where they might not always be trusted. So it's a completely new monster here, and lots of things to be developed here still. Yeah, that's what I wanted to share. Thanks a lot for your time.
Thank you so much.